Okay, welcome back, Math 20-3. We are in the first 4.1, trigonometry of right triangles. And I know that you got some situations that have some complex questions where there's multiple triangles in one. And so I'm going to provide you some examples that show how could you apply some of the techniques that we learned from basic triangles to solve application questions. All right, and I got 3 examples that kind of model the ones you have in your practice problems and build your skills. All right, so this first question is on the screen where it says, what is the angle of descent? All right, so what that means is where the angle of descent is down here. It says, what's this angle of this triangle here? Okay. So with these types of problems, you kind of see that there's typically 2 large triangles connected together. And you often want to solve, first and foremost, the connecting side length. Because if you have the connecting side length solved, you've got, if you had this, you've got one piece of information, and then you can find a third. Okay? So that's the goal typically, is to first find the connected side length, and then with that, if we had that, we'd have another side length, and then we can figure out 2 comparable ratios, or at least a ratio between the 2. Using our trigonometry, we can solve for x. Okay, so I'm just going to erase what I just did here, and we're going to find this dotted line. Okay, now we're going to look at what do we have on the other side. Well, we've got this triangle I can sort of see here. I can even just sort of shade it with a little bit of yellow. Although that probably is not very visible. Okay. We have a triangle here on the left-hand side. And because if this is a right triangle here, this should, in theory, still also be a right triangle value there. We have the angle, or the referent angle, so I'm now going to work with green. Here we have a referent angle here. We don't know what this is, and we don't seem to care about the bottom space here. Again, there's a right angle here. It appears that we have the hypotenuse, and we're looking for this side over here, which is the opposite. So we're working with the opposite and hypotenuse. I'll go switch back to my blue. That the relationship between the opposite and hypotenuse is the sine. So sine of an angle, and I'll put over 1 because we're looking for side length, is opposite over hypotenuse. And this time we're given the angle, so sine of 40 over here over 1 is the opposite, which we don't know, and the hypotenuse is 50. So it appears at this particular junction that the final answer is going to be involving going from 1 to 50. But we don't know what this is. We need to go sine of 40. And I apologize, I kind of ran out of space there. But I guess I can move up a little bit and come back. And like I've been doing before, this is not very useful unless we put it into a number. So we can go and say, well, what's sine of 40? So we can say 40, and then what is the sine? Which is approximately 0.642, and the last digit 7, but it rounds up because the one beside is above 5, so 8 roughly over 1 is equal to some question mark over 50. And we already just said that if we have to go from 1 to 50, we're going to need to multiply that by 50 and then times that by 50 because of proportional reasoning. So in the calculator, I already have that value, so I times that by 50. So it says that that vertical height is approximately 32.139380. Okay, we don't really need much more precision than 4 decimal places, but that's that vertical height. I'll go back up. That is the height of this dotted line right here. Okay, so now we've established that's about 32.1. We'll keep the precision in our calculator right now. This is about 32.1. Okay, and we're looking for this angle. here's a right angle. So looking at this new triangle on the right-hand side, we have an angle, we have a right angle. Oh, we're given information about the adjacent between the values. And up here, this is the opposite as well. So the relationship between this opposite and this adjacent is tangent. Tangent of an angle, and then we're looking for an angle, so I'm not going to put over 1, is going to be opposite divided by the adjacent. And so tangent of an angle is equal to opposite, which is 32.1, and all those decimals that come from here, all over 30. So what we're going to do is we're going to take this big number that we have here, divide that by 30, and that's going to be our tangent of the angle. So I can literally just go divide by 30. So the tangent is approximately 1 point, I'll put the approximate symbol here, 1.071312. Now that's the tangent, that's not the angle. If we want to find the angle, we need to untangent it. You can use the chart and find the closest angle to that, or you can use the calculator and say untangent or inverse tangent of 1.071312. Which, because on my calculator, I just go second function, tangent. Untangent that thing, and tell me what the angle is. 46.97. So that really rounds up to about 47 degrees. So x, which is the angle theta, is about 47 degrees. Okay. Let me just zoom out to this one here. I believe that this is one that's an application, which is very practical. Okay, let me zoom in a little bit. Oh, that might be a little too much. Alright, so in construction, as per the curriculum, it says, please make sure all application questions deal with construction as the primary base, is what they suggest. And so here is a set of trusses, or at least the cutout section of what a truss could look like for a roof of a building. This would connect to the ceiling down here, and this would be your roof that you'd sheet over and put your siding or your shingling and or your roof tin, whatever you want to put on it, or if you're building a nice little shed. Okay. Now, when building trusses, as long as you establish the pitch, which is basically telling you bits and pieces about the angle, you can piece out, or the person who manufactures this can figure out the template of the heights per trusses as they're built. Now we're told that the span between each of the trusses is 4 feet. That's pretty spacious, and may not even be to code, but we'll go with that dimension. So 4 feet is this value. So between every truss, there's 4 feet. There's 4 feet. There's another 4 feet. There's another 4 feet. Now the question is, what's the BH height? So we're going to need to know this one here. Okay? Now, that is in between here. So we kind of need to know the distance all the way from here to here. And looking at 4 feet, 4 feet, 4 feet, 4 feet, it looks like we have 16 feet. Okay? Now, we've got the fact that the referent angle to that space is 30 degrees. So theta is 30 degrees. And we're trying to find out this one particular height over here. And that is related to the opposite of that referent angle over here. And because we're going to assume these trusses are built perfectly well and upright, and or perpendicular to the the base plate of the truss, that we want to say that's a right angle, and therefore this should be the adjacent, because that sits between the referent angle and the right angle. We have opposite, we have adjacent, so therefore we can work with a tangent of an angle, and because we're looking for side lengths, we're going to put over 1. Now there's going to be a little bonus question about this one in a moment. Tangent over 1 is opposite over the adjacent, and the opposite we don't know. We know the tangent has 30 degrees over 1, and we know the adjacent this time is 16 feet. We said before that this is not very useful. We need to put that as a decimal format so we can work with this for proportional reasoning of some sort. So we type in 30 degrees, and we want to know the tangent of it. Okay, so this is about 0.577, and I'll even round it up to 4, because that's probably what your chart has on your formula sheet. Over 1 equals some question mark over 16. Back to green. All right, so going from 1 to 16 is our proportions given. So times that by 16. Times that by 16. So therefore, our answer for this opposite height of this one particular truss is 0.577. 4 times 16. And because it's already a calculator, I'll just go times 16. So the truss height for that one on B to H is about 9.237, okay, or roughly 9.2 feet. Now, no contractor would be pleased with 9.2 feet. You would want to actually figure out what those are in inches, the parts that not are feet, okay. So I know this is going to be 9 feet in some portion of inches. So again, I would just take away the 9. Say it's 9 feet. Take away the 9 in your calculator. So subtract 9. Now this is the percentage of a foot. Now let's convert those to inches. If you could recall how to convert that, there's a shortcut, times that by 12, and it will give you the approximate number of inches you need. So that's going to be about 9 foot 3. Whoa. What just happened there? But not exactly that. 9 foot 3, 2 or 2.85, and then you could even go further and say what's the 0.85 of a 1 inch, and it could be like even the fact that it's bigger than 3/4. I mean, you can keep going if you really wanted to, but for our intents and purposes, 9.2 feet would have been fine. But telling a manufacturer of a truss, that's not going to be very sufficient. You can even keep going if you really want to. -2. And how many parts in an inch? Well, it depends on the precision you want. I'd say divide by or times 16, because there's how many sixteenths of an inch? Well, it's 13.6. So you can even keep going if you really wanted to. 9 foot 3 inches and 13/16, but it's not even 13ths. It's almost a 14th. So if I went and anyways, divide that back by 16. Change my precision to 32. 27/30 seconds is even more precise if I was using that. Okay, anyways, that doesn't really matter. However, I'm going to add a little bonus question to the idea of this, because I know there's one of the questions in your homework practice that kind of asks, well, what's the distance between along the angle here? I'll put it in red. Well, what's this? How far of sheeting is it between the trusses on the angle? That's a pretty fair question. Okay? Because you want to make sure you have enough to span those two. Now, this is, and they don't even give you these ones here, and often they just give you this. Okay? So if this idea carries on, now that's getting pretty messy here. I'm going to do a little bit of erasing. Okay? Still going to ask the question, what is the distance here? Okay? Now, there's a bit of an assumption that you can draw parallel lines, namely a line like this, and then if you wanted to start here and draw a line like this. Okay? As such, what does that do? Doesn't seem like much. What it does do is it provides us that this angle here is the same, hopefully, as this angle here, that this is 30 degrees. Okay? And because we have the span between these two trusses, this is 4 feet. We can figure out this is pretty much the same question as figuring out this one. Okay? This is 4 feet, this is 30 degrees, and there's a hypotenuse. We have, I know it's pretty messy, we've got an adjacent, which is at 4 feet. We have a hypotenuse, which is that angled piece, and we have an angle. So we can use an adjacent and hypotenuse relationship to figure out what portion or what amount is the sheeting between those two trusses. Okay, so what relates the hypotenuse and adjacent? Well, that's going to be the cosine. Over 1 is adjacent over hypotenuse. The adjacent is 4 feet. We don't know the hypotenuse. We can call that x or a question mark. The cosine, the angle still stays the same all the way from here, so it's 30 degrees. And we're going to put it over 1 because it's much more convenient when working with this for solving proportional reasoning. Okay, cos 30 is not very useful as a value to work with, so we want to figure out what is the cosine of 30 as a decimal. 30, take the cosine of it, and therefore we get our 0.866, and equals 4 over x. So we're trying to go from 1 to x. We don't know how to multiply there. Similarly, we're trying to go from 0.866 to 4. And we're figuring out what's the multiplier to get there. Again, the trick is to take the bigger number, divide by the smaller number to find the multiplier. So I'm just going to go like this. I even can go to the screen. 4 divided by 0.8660 says if we multiply approximately by 4.6189, that will give us to 4. So therefore, times 4.6189, that will give us x. So x is approximately equal to, and we're going to use the 1 decimals fine for this particular purpose, 4.6, and our unit, feet. Okay, now I know that you have a triangle problem that has multiple triangles laid out upon each other for one of your practice questions, and that might be why you're asking help and saying, well, how do I do that question? This is going to be similar setup, okay? Going to erase my annotations here. I guess I could do the quick way. Uh-oh. There we go. All right, last one. Again, I found a problem that's very similar to one of your practice problems that you've been assigned to do. And here's the question where it says, what's the perimeter of this figure? Okay. Let me get rid of this guy for a little bit. Now, the perimeter means find out all the side lengths. Now, I can see it's a quadrilateral because I've got 1, 2, 3, 4 sides. I happen to have 2 of them. We need to figure out the other 2 sides. It seems like this problem is very difficult, because we don't seem to see any right triangles. I kind of assume for a single moment here, though, that there is, in fact, a square here. Okay. It doesn't seem to be useful right now at all. We're going to have to do some cutting of this thing to see if we can figure out where could we, in fact, get the perimeter. And literally, I'm just looking at it kind of stumped myself for a moment, and I'm thinking here might be a good place. I'll just do it in blue to grab, in fact, a cut of this thing. And assume for a single moment that I've got that length here. And it seems like, well, that doesn't seem like very useful information. And I'm also going to do one, I think, because I got a square, I got an angle here, I can figure out that length here. And I'm going to do one that's got, I'm going to cut down here. I'm going to cut a right angle here as well. Whoops. And it's a matter of choice. So let's see what just happened. Because as a result, by the way, I cut these things here. I had a 50. That's a 90. So that means the remainder of this angle inside this part, just in case we needed it, happens to be 40, because these three angles, 50, 90, and this angle here, has got to add up to 180. So what we have is that the 50 and 40 make up your other 90, and there's the other 90 here. This is 40. So if this is 40 here, and this full angle was 100, that makes this little bit here 60. Okay. Doesn't seem like we've done a lot, but we've actually been able to help us solve quite a bit of things. All right. So what I'm going to do is I'm going to solve this little triangle coming from here. I'm going to even just redraw it really quickly in green, I guess. The information provided now on that little triangle up there is the fact that this is a, oops, changed my pen, 60 degrees, and that's 200. Okay, and ultimately I want to actually figure out what is this length here, because that length on the right hand side, which is this little one here, will actually be part of B. It'll be the same distance across. Okay, so this is the reference angle. We'll assume it's 90 degrees. This is the opposite. This is the hypotenuse. Opposite and hypotenuse are sine. And we're solving for side length, so I'm going to put over 1. Opposite over hypotenuse. Opposite we don't know. Hypotenuse is 200. I'm kind of writing sloppy. And then sine of 60 over 1. Again, I'll try to be consistent. We don't know what that is in and of itself, so we put it into a decimal format. Now I'll bring my calculator back on the screen, just in case you want to follow along what I'm doing. So we want to figure out the sine of 60, so 60, take the sine of it, 0.8660. Kind of sound familiar from before. 0.8660 over 1 equals a question mark over 200. I can go from 1 to 200 fairly easily by saying times 200. So times 200. Okay, so times that by 200. And that question mark is 173. And I'll put 0.2, and that's meters. Now what is that? That's this spot over here, which really all I've done is said that this length right from here to here is 173.2. Well, that's good because that's part of B. All right, so now I'm going to switch modes and go down to this big triangle down here. Okay, I know these are confusing questions because there's like lots of parts to them. I'm going to redraw my information here, here, here. And I'll fill in the information I have. I've got a 50. That's actually all I really need. I have part of B here. I got 500. That's all I really have. Okay, meters. Now I can figure out this part here, and then I'll have all of the part of B, because this part we already got is 173, and then I'll know what B is if I figure out this little bit. So let's work with that. I made this perpendicular. I have an angle. I have a right angle, and that must be the adjacent, because between those two angles, and this is still the hypotenuse. So relating those values, adjacent and hypotenuse, will come back to my screen, is cosine. Cosine of an angle over 1 is adjacent over hypotenuse. Cosine of 50 over 1 is the adjacent, we don't know, over 500. And procedurally, again, we want to know what that is. So as a number of cosine 50, so clear my screen, 50, take the cosine, It's about 0.6428. Rounding that 7 up there. 2 and 8 over 1 equals some question mark over 500. Now I'm going a little fast. I'm trying to get through this with saving some recording time. Going from 1 to 500 times 500 times 500. And that will give us this part of B here. Okay, so 500 times 0.606428. But again, it's in my calculator, so I'll just go times that by 500. And voila, there's that question mark is 321.3. 9, etc. So now what we've got is this length from here to here is 321.39. I'll keep that for now. Okay. And this is 173.2. So if we add them together, we've got the length of B. So I'm just going to plus 173.2. And it's about 494.6. So we've only got this done. Okay. Oh, this is half the problem so far. Okay, so we've established doing all this work, and we've only got the value of B, because we have B plus 500 plus 200. We still need to figure out A. I'm going to do a little bit of erasing here yet again. I should probably keep those numbers written down. I got 494.6, and I've got that. Yeah, that's all I really need to keep track of. Okay, I'm going to erase all my annotations here. Undo. I think I have to hold the mouse button down, isn't it? Nope. I gotta hold the mouse button down. There we go. Erase the annotations. There's what I want. Alright. Okay, so now I want to be able to figure out A. Still do it, keeping this idea in mind. I've got this thing subdivided. And we knew that this value here was 60 degrees, and we can figure out all of this length on the bottom and then take away this little length over here. Okay, that's going to be one of the strategies we're going to do, is we want to figure out all of this guy and then take away this little guy. Now the big guy can be solved from the bottom triangle again. So I'm just going to draw them this way. Well, I guess I'll just use my lines quickly. So here's the big line. Alright, back to a pen. We got 50 degrees and we have 500. And if I want to know this big line here, that is the opposite of 50, and this is still the hypotenuse. Okay, so relating these two, we're going to use the sine of the angle over 1 is opposite over hypotenuse. So sine of 50, oh, glitchy there, is equal to, we don't know, over 500. Okay, being consistent, we want to make sure that we convert this sine 50 into a number. I know it's getting pretty sloppy there because I'm at the far left, and I'm writing on a very balanced little board here. So sine 50, well, we have our calculator, clear that thing off. 50 sine 0.7660. 0.7660 over 1 is a question mark over 500. We go from 1 to 500 by timesing that by 500. So we take that number 0.76 we just got in our calculator and times that by 500. And that gives us 383. So this big length here is 383. All right, so that's this whole length here. That's not A, that's all of this part from A. So now we got to figure out this little bit from this triangle here, take that away, and then we got all of A. I'm now going to just work in this little space here, because I can. I got a little triangle that's got, here we go. I'll fill it in with some green numbers. We got 60 degrees, and we have 200. And I want to know what this one is here to take that away. Okay. Here's the referent angle, 60. That's the adjacent. Because I'm assuming that when I cut all that stuff up, it was perpendiculars. Okay, that's the adjacent, and there's the hypotenuse. Okay, adjacent, hypotenuse, and it's all over the board, literally, is in fact cosine. Relates those two. So cosine this time over 1 is this adjacent over hypotenuse. We don't know what the adjacent is. The hypotenuse is 200. And the cosine of 60 over 1. Again, we want to get that to a number. And so we go back to our handy-dandy calculator, put the 60 degrees in, and then we go cosine. Yay, it's an easy number this time. 0.5 over 1 equals some number over 200. So going from 1 to 200, times that by 200. Yay. 0.5 times 200. You can use a calculator, but mentally it's half of 200. So that little length here is 100 meters. Wow. So we've established that this whole big line here, I guess I'll draw it in red now, I'll scribble red. This big line that I'm just drawing right now is 383. And this little thing's 100. So that means this A part right here, which is the same length, this part right here is 383 minus 100, so 283. 283. Whew. Okay. 99% done this question. I'm going to do a bit of erasing on my ugly diagram. 283. Done. Good. I'm going to go move this over a little bit. We did all that work before to figure out what B was. That was, I have that written down, 494.6, or roughly 495. Okay? And now the perimeter is side plus side plus side plus side. It's going to be 283 plus 495 that we just calculated, then 500, and then 200. And if you want to use a calculator at that point, go right ahead. So 283 plus 495 plus 500 plus 200 equals 1478. Okay, so that's the perimeter of this figure. And it relates to one of the questions you're having to do where you have to cut up part of your composite figure in order to figure out your parts of your sides, and then in the end I believe you have to add them all up as well for a perimeter problem. Okay, that is it for this video of the advanced problems of basic trigonometry.